Hello everybody, we're here at Microsoft again for another whiteboarding video. This time it's on Azure Virtual WAN, and we're here today with Stephane Budo.
That's right.
And this being recorded on August 22? August 26, Monday. So we will be, it's a bit of a preface, we will be mentioning some stuff that is not just here yet, but things are coming. So please check the documentation site online for when things are coming. But that's just a bit of a disclaimer to start with. Okay, Steph.
Hi.
Talk to us about Azure Virtual WAN, what it is, and also taking into consideration everything behind what we need to understand as a customer or a person wanting to implement this to get the best performance. They need to understand all the other concepts we've got.
Okay. How much time do you have?
We've got about just under 30 minutes.
Excellent. We got to go way back first, right? Before we start to introduce the concept of Azure Virtual WAN, let's talk more about networking in general, networking in Azure, networking at Microsoft, and go backwards. So the first thing really we need to understand is Microsoft has become the second largest global network on the planet. I mean, right, believe it or not. So we've got a great slide that Mark will now work into the video that shows what Microsoft's at this stage, what the global reach is, right? So we've got POPs, point of presence, edges peering everywhere across the globe, right? And this is really where the power of the Microsoft network becomes really interesting, because you can get from one point of the planet to the other at a very low latency, very high bandwidth when you utilize that. And we'll come later to how that interacts with Azure Virtual WAN.
So just go through that list again. You got POPs.
You got POPs, you got edges, you got peering locations, right?
And POPs and edges are pretty much the same.
Pretty much the same. So think of it, well, let's go one step back and say, well, first of all, you have the Azure data centers, right? Traditionally, the Azure data centers were your POPs and edge incoming points. So there's 54 plus data centers, and as I speak, there's probably another one being built somewhere. Now, Microsoft decided to go, we got to get out of that and start to establish more presence across the globe where there is no data center to be able to come into that global network. And this is where those POP and edges come into play, right? So there's things like in Auckland, for example, there you go, there's a POP. There's no data center, but there's a POP. Fantastic. New Zealand, Australia connectivity, beautiful. So that's more close to home, of course, but there's Taipei, there's multiple locations, and we've got like 200 plus, I believe, at this stage, where we've got really a point of presence when there is no data center to enter that global edge network. All right, so traditionally, back in the days, if somebody in Perth, for example, wanted to access the Sydney data center in Azure, what would they have to do? Well, just the internet. And as we all know, crossing the big deserts takes a long time. The latency is just awful. So what these Microsoft Edges will do for you is that a user sitting in an internet cafe somewhere in Perth can actually, right here, can actually connect to one of those POPs, and through the Microsoft network, through the Microsoft global network reach, get onto a presence, right? Get back to Sydney data center, get back to Melbourne data center at a much faster rate than it would take to go through the internet. Now, in comparison with some of the Microsoft competitors, and this is public knowledge, so we can just divulge this, AWS, for example, has more the tendency of flogging about the routing of anything outside to the internet, as opposed to Microsoft has really that idea of saying, let's bring that all in as fast as possible onto the edge network so that we can carry all that traffic and go as fast as possible through wherever the location the end user data needs to get, the end user traffic needs to get. So that's what those edge POPs are really good for, right? So when we talk about this, we then lead into the Office 365 story. Now, you probably have heard a lot about Office 365 through the internet versus Office 365 through peering versus Office 365 through ExpressRoute. Let's make one thing clear. The best methodology to get to Office 365 is the internet. There's no way around that. The majority of the investment from Microsoft goes towards Office 365 access on that internet. right? So you want to split that traffic as fast as possible coming off your end device, coming off your network. You want to go as fast as possible on the internet to get to Office 365, and you want to go as fast as possible to the edge network when it comes down to all your traffic destined to your Sydney data center, your Azure data center, etc., etc.
Okay, you might want to actually just on that with just a quick recap. The POP sites / edge sites, they're all scattered across the globe. There's over 140 of them, more than what regions we've got. So it's bringing the Microsoft services closer to the customer. Correct. So it's much quicker. And also, too, if customers want to look at where they're situated, they can go to a public website. peeringdb.com.
Yes, that's
Type in our ASN 8075. It'll come up with a list of all our POP sites.
That's right,
and where they're located.
Yep, absolutely.
Now, I was going to ask you something just quickly.
Yep.
Because we're talking about how speed of connectivity with Office 365 versus Azure and over the public internet versus your WAN. Do you want to draw up on the board for us a classic diagram of the current WAN today with the hairpinning effect, with all the internet going out through like a colo, for example, like a hairpinning type of thing scenario.
Right.
Just so users can understand what they're up against today, just quickly, because we've got a slide also to cover this.
Oh yeah, we do too. We should put that on. So basically, you look at, you are here. So you are a beautiful end user and you have an incoming point, and let's represent the internet. Okay, now your data center sits here, DC is here, and let's say Office 365 is there. So this is the Microsoft side of things. Okay, now you an end user here, say for example, you might need to connect to your DC. Now the traditional methodology would be you either go VPN across on the internet, or some other might say you've got over the internet, you end up on an MPLS network, and then that goes to your DC. Now from your DC, you might have an ExpressRoute connection. ExpressRoute traditionally will go to Azure, so you might have an ExpressRoute here, and that ExpressRoute might actually go to Office 365 as well. Same circuits, two separate peerings. Now, say you're here and you're trying to access your Outlook. Now, your Outlook will then go, oh, hang on a minute, I'm going to route back to my DC. From my DC, through my MPLS and my internet, I might actually go back to the Office 365 here. Now, this one is going to have to come back all the way to the DC and then come back all the way here, unless you start segregating traffic and say, hang on, when I'm here, because there is a great connectivity here with those gateways, come from here straight to the internet down there. Now, there's a few things here that are into play, of course, is where are you located here versus where do you need to access your resources, and how many hops are you going to go through on the internet to actually get to that. This is where those POP becomes quite interesting, because you can actually stop there and say, let's go to a Microsoft POP that is close to me, and then carry all the traffic through the Microsoft Edge network all the way. And this is where this diagram is really interesting, because what we can see here is that you've got a user sitting in England trying to access a data center in India, in Azure. Now you can see here you've got all the different POPs along with the number of hops with the different POPs that will go through to get there, let alone all the different type of route that you can take. So you can really go, oh, right now the traffic will go from one route, or the next packet will go to a different route, and it's all different latency, it's all different routes, it's all everything different. Now, when we look at what Microsoft Edge and Microsoft POPs can do for you, at this stage your end user will connect to the POP, and then from there it will be carried all the way to India through the Microsoft Edge network. And this is where the Microsoft network becomes really attractive, because at that point you no longer have the potential diversity in the route that you're going to take, because you know it's always going to go through the Microsoft Edge. It's going to be a lot faster, a lot more bandwidth. I mean, the bandwidth right now is sitting at, what did we say, Mark? 1.6
petabytes between data centers.
I mean, amazing, right? 1.6 petabytes. Who would ever need that kind of resources? But here we go. So in terms of the regional architecture that we see that Microsoft has implemented, if you look at the Microsoft backbone, each of the backbone will then have a regional hub, a regional point of presence that will connect to each of the DCs that are in a region. So, for example, a big misnomer to say when you deploy a VNet, and Mark and I were just discussing this, is you deploy a VNet, you do not deploy a VNet in a data center. You deploy a VNet at the regional point. Why? Because you might have virtual machines, VNets, that are across VNet peering, etc., etc. So you need the bandwidth in between those things. Right, and this is where the bandwidth become really interesting, and the latency between all these different DCs. Now, moving on to virtual WAN.
It's 10 minutes on. We haven't talked about virtual WAN, but this is good because we need to understand the behind the scenes, how it all fits together, and the benefits of our network to help with Azure Virtual WAN.
You got to stop me.
That's part of the story.
First of all, let's talk about MPLS versus SD-WAN. Now, for those who don't know quickly what SDN and MPLS is, MPLS is your traditional older methodology of connecting two sites together, right? Whereby a provider will give you a private IP so that you can connect those two things together. Now, there's been a recent reports on, the security of those things. It's unencrypted traffic between two sites. So the question is always, how secure is an MPLS network? This is not the subject of this talk today, but look into it because there's quite some scary stuff happening on there. Now, SD-WAN is really a technology that was introduced to start to use the internet as a WAN technology to replace that MPLS, right? Which is a lot cheaper, of course. So now what will happen is a provider will create SD-WAN devices, will deploy those devices, you plug it into your internet connection onto those devices, bang, you have an instant WAN. How beautiful is that? It's all encrypted, of course, because it goes across the internet. Mm-hmm. So you got strong encryption. The provider is responsible for that. And you also have the ease of use, because traditionally those devices will be managed through a central console, and all you have to do really is plug it in onto the internet, it will self-declare itself to a management console, and there is your WAN. How good is that?
Easy. So even your receptionist could literally plug it into the branch site.
Plug it in and it's done. So you get a brand new site somewhere out. You don't need any technical people. You just send out the device. They plug in the whatever internet connectivity they've got. Boom, you're on the WAN.
Perfect.
How good is that? All right. So now SD-WAN. Microsoft thought of that and thought, well, hang on a minute. How can we utilize that kind of technology using our edge network? And this is where it becomes really interesting, is that instead of just doing the internet and go across the internet for everything, why don't we use the internet as the last mile and say, we're going to connect through an SD-WAN to the first point of presence, the closest possible edge income, the closest possible point of presence that Microsoft has, and then use our internal network, the edge network, to do all the communication.
So in other words, it's the same as an Office 365 user as such. They're sitting in an internet cafe, they connect to, say, outlook.office365.com. They're sitting in Perth, then automatically they connect in through a POP site in Perth, and then comes into our network, same as an SD-WAN device. Yep. A branch site in Perth will connect and
that's right.
Hit the local POP.
This is where the story expands, right? Because when we talk about Azure Virtual WAN, we get different type of connectivity. Right? We can do branch offices, so we can have 1,000 offices that are all connected through one big WAN, right? Which then will connect through the actual Microsoft Edge network all together, beautiful. And then in addition to that, you can then also have all the, what we call the point to site, which is all the individual users from an internet cafe going to the closest possible POP, bang, coming down to your network through the Microsoft Edge. How beautiful is that? I mean, great. And then it doesn't stop there, because go back to our previous video on ExpressRoute. Get this: you can actually connect ExpressRoute to SD-WAN to Virtual WAN as well, so that you can have your DC connected to your SD-WAN, as in Azure Virtual WAN, as well as all your branch offices and your remote workers all talking together, one happy family. How is that? That's brilliant. Okay, diagram it. So we've got actually a PowerPoint presentation here running. So basically here is exactly what I just described. You have all your branches that are connecting to what we call a hub. Now, when we talk about how to set up the actual virtual WAN, you're going to create a hub per region. And these branch offices, endpoint people, will connect to a hub, will end up somewhere on or in a region within Microsoft. Now you need a hub, you can only have one hub per region, and you need a region per hub traditionally, because you can still connect if you want to an office that is sitting in Mumbai to connect back to a hub in Sydney. There's no problem. But then beware that you will use the internet to get all the way there. So,
but it could potentially, if there's a POP in Mumbai, your device could connect via the POP.
Then there, and then come
Microsoft's backbone across to the hub.
Correct, that's right. Now, at this stage, there is no connectivity in public, in general availability between two hubs. But it's in private.
It's coming.
It's coming. So we're getting there. Now, once you have that connectivity established between, almost the wrong pen there, between all your branch offices and your hub, they will automatically be able to communicate. Why? The power of BGP. We love BGP. Go back to the ExpressRoute if you don't know what BGP is. Anyway, so BGP will advertise all the routes, so any new branch office you connect, boom, it's available. All the branch offices can communicate with it. Fantastic. Now, last but not least, we spoke about ExpressRoute connecting, but of course you can also connect all your VNets to this. So now, not only your DC is connected to your WAN through Virtual WAN, Azure Virtual WAN, but also your VNets in Azure, which is really, it was originally the primary use for this, is to go back to the VNet in Azure. But if you have a DC on-prem and it uses ExpressRoute, or if it doesn't even, you can still use the internet with SD-WAN. How good's that, right? Brilliant.
So let's play out some scenarios, I guess, with looking at traditional MPLS versus, I think SD-WAN is the next one versus, I know you've covered them, but just talk to the diagrams.
No, that's right. Yeah, absolutely. Yeah.
Play out the scenario.
So in the traditional methodology, you would start with an MPLS network. Each of those sites will then connect to that MPLS network. Then you can get a third-party provider to give you an ExpressRoute connection, which on layer 3 will then connect to that MPLS and become just another site effectively to hook you up to a gateway that will sit in Azure that will then connect to all your VNets. Now, in addition to that, for those branch offices, traditionally, internet connectivity is then centralized through a data center to go to the Office 365, etc., etc. Or each of the branch will have a separate internet connection to actually get out and do that. That's really the traditional, what you see most in the larger enterprise these days. Now, when we evolve from that, when we say, okay, what about SD-WAN? Well, SD-WAN will deliver to your branch offices the same as what an MPLS will do at a fraction of the cost, because all it needs is an internet tail, and from there it will hook up to basically your global network and then go back down through your SD-WAN virtual appliance inside of Azure. Okay, so this is effectively doing what Azure Virtual WAN would do, but yourself, right? So get a third-party appliance in your VNet in the Azure, and boom, connect it all up through the internet. Okay. Now, when we go further with this story, we then introduce Azure Virtual WAN.
So can I just, my analogy,
go,
do you remember He-Man, the cartoon?
Oh yeah.
And remember the battle, the Cringer, you remember Cringer, his cat?
Yeah.
And when he went by the powers of Grayskull and he turned into a battle cat?
Yeah.
Yeah.
That's right.
It's like
that's
Azure Virtual WAN on top of SD-WAN.
That's exactly right. So let's face it, you think about Azure Virtual WAN, it's really SD-WAN but on steroids.
It's like Clark Kent turning into Superman.
That's exactly right. That's right. They're one and the same, but one's better. All right, so Azure Virtual WAN is the same principle in the background, except that you get a lot closer to the edge through those POPs. So you don't have to go all the way across the internet from one location to another. You just literally go from one location, of course encrypted through an IPsec tunnel, to the first available POP. And then from there, you effectively use the internal Microsoft's global network, edge network, to get to Azure Virtual WAN, to Azure Hub, to then get to your VNet, or from there, get this, Office 365. How good is that? So now you're avoiding all those different little hops that you can get out on the internet. Same principle with ExpressRoute is, of course, also connected, in this case, to your POP through your third-party provider, whoever you're using, that goes back to the virtual hub, the Azure Virtual WAN hub, that then goes back to your VNet. Now, this here, and sorry, I'm getting a bit messy on my diagram here, but this is what's to come. So keep an eye out for this. It's coming very soon in your local provider, in your local region. So yeah, keep an eye out for this.
Before you go next slide,
Yeah.
You might want to cover it. Just remind as well, say from this Cairns branch up here at the top left, traffic to Office 365 is local SaaS or local internet breakout, which is a policy on the SD-WAN device, pushes it out to the public internet.
Now, one of the actually what Mark's points just reminded me to remind people of is. There's really two ways of connecting with Azure Virtual WAN. You can use an appliance and go to your favorite, distributor for that. Whoever, we won't name anyone now because we don't want to make any preferences. But you'll see on the website there's a lot of providers, or you can do it yourself. If the list is not in there, if who you're looking for is not in there, you can buy your preferred VPN concentrator or whatever and do all the management yourself. It's a lot easier when you use one of the providers, obviously, but because they take care of all the breakouts, as in they take care of the route splitting and everything else baked into the device.
Based on what SaaS traffic versus
correct. So when you buy one of those appliances, the appliance is pre-configured already for Azure Virtual WAN. Therefore, they know, hey, hang on a minute, if I need to go to Office 365, split over there, please. If I need to go to my VNets, come over here. It's all done. If you're using your own, you've got to take care of that yourself. Not that it's hard, but it's one of those services that is provided. Same as central management. It's back to the SD-WAN, good old adage. Okay, so now one of the scenarios would be the coexistence between the two, MPLS and SD-WAN. Now, why would you do that, one may ask? Well, you could potentially do backups. Say you've got your primary MPLS provider and you're establishing an MPLS, an SD-WAN connectivity network outside of that as a backup just in case the MPLS goes down, or you migrating away from MPLS, whatever the case may be. So in this case, we can see on the diagram, you get your traditional MPLS network with your connectivity back to your branches and also your data center, of course. You can then use the internet on the SD-WAN to actually go through here, potentially to another site or to your data center, as well as go back down there to your hub. In this case, if you use, of course, Azure Virtual WAN.
So this is more of a MPLS/SD-WAN/Azure Virtual WAN
Azure Virtual WAN.
together.
I believe the next slide is actually. Oh no, it's
before we go further, you might want to draw like an arrow here saying coming soon.
Yeah, that's right. Coming soon.
Yeah, cool.
So keep an eye on that.
Hub to hub,
it's
on the
coming
way.
very soon. All right. So, well, that's actually an interesting slide because it's already been depicted there. So, but this is definitely the coming soon side, of things. So this diagram. It's more high level to show you that you will, if you're sitting in Sydney branch, you'll hit the Sydney POP to get onto that Microsoft Global Network, the Edge network. Same if you're in Perth, you'll hit the Perth POP. That's very hard to say.
Perth POP,
right?
yes.
That's it. Yeah. Same with the, if you go on Melbourne, etc., etc. So where you are, this has really become interesting. If you're sitting in Wellington, in Auckland, in New Zealand, you don't have to go across the internet, across the ditch to come all the way back to Sydney. You can just hit the local POP and let Microsoft carry the traffic across for you, because it's a lot cheaper than to get a MPLS connection across that ditch. Make sense? All right. Well, that's pretty much, unless Mark, if you have any other questions, but that pretty much is Azure Virtual WAN in a nutshell in
25 minutes.
25 minutes.
And just on the hub-to-hub thing, at the moment, there's nothing stopping you. If you've got a SD-WAN appliance in LA, for example, and another one in an SD-WAN appliance in, say, Perth, you can connect them to the same hub in, say, Australia East, for example.
Exactly right. No problems at all. It's just beware that you will cross the internet through those POPs first to get to the closest possible.
And there's limitations as well with one hub as well, which is, 20 gigabits per second.
Actually, those limitations, good point, because I forgot about those. They are amazing. They're limitations, but 2 gigabits per site, 2 gigabit per site, 20 gigabit per hub, 1,000 branch sites per hub, and 10,000 point-to-site connection per hub. So you can have 10,000 employees connecting to the same hub. You can have 1,000 branch office connecting to the same hub. You get up to 20 gigabits of internal communication through that hub for each of your sites. How good is that?
Excellent.
So it's brilliant. Just go check it out. Very easy to set up. I actually set one up in my lab when it came out. Took me, I don't know, without appliance, without the help of a vendor appliance, it took me an hour and I was all set up. So it's very easy.
And Steph, what about, we talk about the management side of things. So with traditional MPLS, you've got your provider who manages the device for the company, which is handy. Moving to SD-WAN, then how's the management come into it?
Yes, there's traditionally no management SD-WAN. You need your internal people to know about it. So, but with the new Microsoft Azure Networking MSP program, you can go to your favorite MSP that is signed up to the program to come and manage those devices for you. So you can go to your favorite vendor for Azure Virtual WAN. You buy those appliances, you set them up, very easy to set up. Then you go talk to your favorite MSP who signed up to the program, and they can come and manage it for you, just like an MPLS network.
So as an example, if you're currently using a provider today for MPLS, that same provider could be a networking MSP
yes.
for SD-WAN.
That's right.
If that's the case, well then you keep the same provider, got the same relationship, go to the same Christmas parties or whatever else, and you're using Azure.
And everybody's happy.
Exactly. Hey, thank you very much, Steph.
No worries. Thanks, Mark.